In this video, I will demonstrate how to use the Random Outcome Check module of Magellan's Compass software. I use the Chrome browser to access Compass, which is running on a local server in this case. Remember to use the help buttons as needed. In the prior Select Best Data Points module video, I demonstrated how to extract biologically relevant information from the dataset by identifying data points with the strongest connection to the biological difference between samples I selected. I can now use this module to compare the decision values of the best performing data points to those that emerge from random noise in the data. There are no user-defined parameters to set here. I simply click the button and Compass will scramble the data such that 50% of the examples in each outcome category are switched to the opposite category. Compass then recalculates the decision values. In other words, Compass scrambles the data labels and determines what decision values result. In this case, I am comparing the proteomics information from the NCI60 breast cancer cell lines with 12 or more replicates for each cell line. This data is from a published study, and the raw mass spec data can be accessed at the PRIDE data repository. A plot is generated for each comparison being made. The ranked decision values from data with correct outcome labels are indicated by the black trend line, which trend line is the same as the one shown in the prior module. The red points indicate decision values that are achieved when the individual abundance values within each data point are no longer connected to outcome. As you can see, correctly connected data gives markedly better decision values than for the scrambled data. Nonetheless, some scrambled data can give higher decision values, and it is important to make sure that any data points selected for deeper analysis in subsequent steps have scores that fall out of this range to avoid potential contamination with meaningless information. While reasonable separation of information from noise is apparent here, it is not always the case. Note that the best data points extracted in another project have little separation from noise generated from randomized data. Such a result is reason for caution in interpretation of the data and suggests changes to the study or its analysis. The function of this module is to rapidly provide the user confidence that the study is sufficiently powered and that the best data points identified are meaningful. It is important to note that this module is not running a true statistical test here, but an algorithmic one. Up next, I will demonstrate the use of the Parse All Examples module, which module will expand Compass analysis to include the entire data.